Hi, I'm Jonathan Everett. The aim of my project was to build a working model of an America's Cup yacht, including front foil angle control. This idea came from discussions with sailors and the disappointment that I, and many other New Zealanders, felt when Emirates Team New Zealand lost the America's Cup last year. I thought the model would be a good toy for adults, but also might be useful for studying foil control. It is not possible to buy a model AC72, so I made my own model, which I call AC 3.5 because the hulls are 3.5 feet long. Before I did that, I made two prototype yachts out of balsa wood and experimented with foiling by suspending them with string in the stream current. I used NASA's Foil Sim simulation program to help design foils that generated sufficient lift to pop the balsa boats onto their foils. I obtained some plans and made my own model AC72 with a number of modifications to enable foil control. I built the hulls and wing sail out of PVC sheet and the frame out of carbon fiber tubing. I used an Arduino microcontroller and servos to control the rudders and the sail. I also used a remote control receiver on the yacht to receive signals from the transmitter that I operated from the shore to pass commands to the yacht's control system. I used Foil Sim to help design two sets of foils, and I made them with our school's 3D printer. I glued them to aluminium dagger boards. I made a gear system from two cogs which sat inside the hulls. The dagger boards connected to the large cogs and the servos were connected to the small cogs. I calibrated the system to move the foils fore and aft in 1 degree increments. To test the foiling, I suspended the yacht in the Tongariro River. This did not work out due to turbulence in the stream flow. In fact, it was almost a disaster as the yacht went side on and capsized, one of the rudders disappeared downstream and all the electronics got soaked. Fortunately, after drying overnight in front of the fire, it all still worked. I had some problems, especially relating to water tightness. The AC 3.5 sunk the first time I sailed it, so I filled it with polystyrene, put the electronics in a waterproof container, and improved the sealing of the hulls and the apron that waterproofed the daggerboard slots. The foils could not maintain position when under load, so I replaced them with much stronger ones. However, this was worse than before, as the entire system wasn't very rigid and even the hulls flexed when the servos changed positions. So I made it again. This time I attached all the parts to a single rigid construction of aluminium tube and set off to the sides of the hulls. This made it as rigid as possible and ensured accurate control of the foils. After making these modifications, I towed the yacht behind a boat at Lake Manahina, and I managed to get it up on the foils, though not for very long. This was because the yacht was getting too much lift and the entire foils were coming out of the water, resulting in a sudden loss of lift, causing the yacht to crash back down. I extended the foils and increased the cant angle to provide a degree of self-regulation of lift. The idea was that the tips of the foils would come out of the water, reducing the lift until it couldn't rise any further, therefore self-stabilizing. I repeated the towing test with more stable foiling results. I wanted to find a relationship between the foil angle of attack and the speed when the yacht popped up onto its foils. I used a modified flow meter held in the water to measure speed, displaying measurements on an LCD. To be certain of the yacht foil angle, I added a duplicate receiver to the flow meter which displayed the signals that were sent to the yacht. Once I had these results, I attached the flow meter to the yacht and programmed an algorithm to move the foil angle of attack to the position that popped the yacht onto its foils at different speeds. I am demonstrating how this works by simulating boat speed using a hairdryer. I sailed the yacht a few times. The sailing mechanisms work really well. I can tack and jibe and adjust the position of the sail. However, I haven't been able to get it to pop up onto the foils while sailing. This is because I'm still learning to sail it, and as yet I have not sailed in wind strong enough to get it up to foiling speed. But I think I have to conclude from these tests and my experience with sailing the yacht so far that it will be very difficult to get it to foil under sail power. Winds strong enough to get AC 3.5 up to foiling speed will produce relatively large waves that will cause significant disturbance. Despite this, AC 3.5 is still a fun toy.